Okay, so we're going to learn our second factoring strategy. What was the first one? Can you guys remind me? That you guys worked with for a couple days now?
What they share.
What they share, what they have in common, also known as
GCF.
GCF, great. So I always just remember that as what they share. So today we're going to learn how to factor another way. I think we've got 4 ways, basically, in this class at least. And we take it further in Algebra 2, but we review these in Algebra 2 as well. So, okay, so this factoring strategy, you know, I don't have a great name for it. And I don't think like anyone has a great name for it. I've never seen a great name for it anyway. So I think the best way to remember it is it's for standard trinomials. So a standard trinomial has the form right here. It has the form ax squared plus bx plus c. So we're going to start with easy standard trinomials. Those are the trinomials that don't really have an a. All the trinomials here, well, they have an a, but what is their a? It's the same on every single one. What's the a on every single one? Remember, a, b, and c are the coefficients. So should a coefficient ever have an x in it?
No.
Remember, a coefficient means the number attached. It should never have a variable in it. So what's the coefficient on the squared term for each one of these trinomials? 1. So the easier trinomials are the ones that have a 1 in front. If you put another number in front, they can still be factored a lot of the time, not every time. But it makes it tougher, so we'll see that in another lesson. Okay? The ones that have something that's not a 1 in front. By the way, these are all trinomials. What kind of trinomials? Can you guys remind me?
All quadratic.
They're all quadratic trinomials, aren't they? Because they're all power of 2? Okay, great. So these are factoring quadratic trinomials. So I think the investigation that you guys did yesterday should have given you a little bit of intuition on how to do this. So here's how you do it. Instead of trying to think of what they share, because by the way, these 3 terms here, they share anything?
6.
Those share an x. Those share a 3, but altogether they don't share anything. There's nothing in common. That's why you can't use that approach. So when you're factoring this way, I think just write down your parentheses first. We had parentheses when we did the other way too, right? We're turning things into a product when we factor. So you should always get a product. And whatever your variable is, I think you want to put that in the first 2 spots. Is this looking familiar from that investigation yesterday?
Yes.
So how do you guess the second 2 spots? If it's a standard trinomial, and it's factorable, by the way, some things don't factor. Some things don't factor. They have imaginary answers, which we're not going to get into this year. But if it does factor, what you've got to do is look at the last number and think about different combinations of that number. So what combinations are there that will give me 18? 6 times 3, or 9 times 2, or right, you could do the other way on each one. I don't write an exhaustive list. When you do this, you shouldn't try to write an exhaustive list. Pretty soon you guys are going to be doing this in your head quick. Everybody in here will, I know. So get a couple down and then start seeing if they work. How do you decide which is the right combination? So here's what I think you want to do is think about which one of these, maybe one of these will work. Which one of these might possibly give you the 3 in the middle? It's the 6 and the 3. See, this is really intuitive. So the 6 and the 3 is going to work. See, when I had the teachers that did this, they made us write a really exhaustive list. And like, use all the, because really 6 times 3 is not negative 18, is it? It'd have to be negative 6 times 3 or negative 3 times 6. And you could start writing down all the combinations. I would just avoid that. Just try to figure out which one of the positive combinations it is first. And now worry about it. We've picked the one we think it is. So now how can we make these add up to negative 3? They can't both be positives, right?
It'd be negative 6 plus 3.
So that's Sheridan's guess. Now check quickly. The key is checking on these. So negative 6 times 3, is that negative 18?
Yeah.
Yes. Negative 6 plus 3, or 3 minus 6, is that going to be negative 3? Yes, so that's the right combination. You want to check these every time. If you get lazy, you're going to make a bunch of mistakes. And you can't make mistakes on these, so do a quick check and it'll save you. get real good at this quick, I promise. That's it, it's factored. We turned something with separating minus signs into a product, which we'll use for all kinds of purposes later, okay? So, what do you guys think for number 2?
Write down the X first.
6 and 10.
Write down the X first, I like that. Here, just there?
No, on both sides.
In both factors, you would say. And then we got to consider multiples that multiply to what?
6 and 10.
60. So 6 and 10 is probably one of your first guesses. Is that the right one? This one's a nice and easy one, isn't it? Should they both be negative? Should one of them be negative? Should any of them be negative?
Positive.
They're both positive. Let's check. 6 times 10, 60. Yes. 6 plus 10, 16. Yes. There you go. So you do not need to write out an exhaustive list of everything. As soon as you find the right combination, you're good to go. Okay? So what do you guys think on number 3? First, write down your quantities, your factors.
Write down the
What goes here?
M.
And, okay. Then we got to think about 20. Well, what would make 20? 10 and 2.
5 and 5.
5
5 and 4.
5 and 4. 20 and 1. Don't forget the 20 and 1, because sometimes that might be the answer.
20 and 1.
So we're looking for a combination of these that somehow adds up to positive 1. Which one of these do you think might somehow do that? I think you want to use your number sense here. 20 and 1 is either going to give you like 19 if you put a negative in there, or 21, or negative 21, something like that, right? It's clearly going to be the 5 and the 4 because there's like 1 in between, right? So don't worry about negative and positive first. That's my advice anyway. Just pick which combination it is. Now start thinking about, okay, one of those probably has to be negative, right? Because they multiply to a negative number. So the question is, are both of them negative? No, that'd give you like negative 9, right? Plus that wouldn't be right. Positive 5?
No.
No. Negative 5.
Negative 5.
Let's say, okay, so negative 5 and positive 4?
No, it's 5.
That's negative 20, yes. But that adds up to negative 1. We want
Yeah, we wanted more.
positive 1, so it's got to be like that, yeah? So don't be afraid to erase there. I think playing guess and check is definitely a good way to go. I think that'll work. Okay? Why don't you guys try some of these bottom ones? I'll give you a second, see if you can nail those. If you're watching the video, I pause it now.
Okay.
All right, let's see if we got these right. So we're supposed to factor these last 3 by looking at combinations. What'd you guys get for this one?
So it would be 8 and 3. Be y plus 8.
8 and 3? 8 times 3 is 24. Oh, y and y, right?
And 8
And 8 plus 3 is 11. Good. Over here, x, x.
8 plus
8 times 5 is 40.
8 and 5.
So
8 and 5.
minus 8.
8 times 5 is 40, I agree.
Negative, negative.
So like that, right?
No, negative, negative.
Because that adds up to positive 13. It's supposed to be
So it's a negative
that times that, negative times negative is positive, and then we get negative 13. So there you go. Okay? Over here,
8. That's durable.
And x and 10. Then negative 10 plus 2.
see, checking Caden. Negative 10 times 2 is negative 20, yes. Negative 10 plus 2 or 2 minus 10 is negative 8, yes. That's as easy as these are. So, don't make them harder than they are.